So welcome everybody to our webinar this afternoon, 1 hour about circular economy, about the use of plastic, about the way we handle and deal with plastics. So I welcome the team here in the room, the team of TNO and the team of Fraunhofer-UMSICHT. I'm very glad to welcome you here as head of the Institute of Fraunhofer-UMSICHT, also as head of the cluster of circular plastics economy. And today we will focus on some of the very important topics regarding the circular economy. So recycling, a very discussed topic, but the circular economy is living for much more. The other R strategies, the way we handle with our resources, and even the way that we use and how we use the plastics that are needed for our comfortable life, and all the way we produce, we consume, and the products that we all like. So this is Esther. Esther, perhaps also a hello from your side, because we both started with this idea to write something and to work together from the TNO and the Fraunhofer side.
Yeah. So welcome everybody. Nice that you have all here at this webinar. My name is Esther van der Beuken. I'm principal consultant at TNO, and I'm looking very much forward to this webinar. And I would like also, you can ask questions during the chat, so please ask your questions and we will answer them after our presentations.
Okay, perfect. Not losing any more time and now going deeply inside this topic, I will hand over to the rest of the people inside this room and come back later to really speak and discuss about your questions, about your topics. So see you in some minutes. Bye.
Well, Manfred, thank you very much for the introduction. Good afternoon, ladies and gentlemen, from my side too. I will first give a short introductory section on the drawbacks and benefits of plastics. My name is Stefan Kawaski, and I am working in the Department Research Management as a project developer for the area of circular economy. Now, a short, not deep dive, but some general remarks on plastics. Plastics presently are shrouded in controversial debates. Aside of their benefits that they have, they are connected to many environmental problems. And that's one of the reasons why we can see the tendency that more and more people think of plastics as something to get rid of. For example, the hashtag plasticfree on Instagram has almost 5 million posts collected now. But from a scientific point of view, we think that neither the business as usual, go on with plastics the way we did until now, is feasible, nor a complete plan. We believe that we need a new sustainable way of designing and using plastics. The history of plastics, you might have seen it several times before, is a success story. Plastics for the last 70 years is the fastest growing bulk material globally. We have around 500 million of tons produced annually. Of these, there are about 400 million of tons of the classical thermoplasts and thermosets, plus additional some 25 million of tons of elastomers, and also very much growing part of synthetic polymer fibers. And this tendency will continue. Plastics will keep up rising in production. That's what most of the projections say. Here are some slides which was prepared from a working group wherein one of the authors of our white paper, Paul Stegmann, was involved. And according to the calculations of this working group, the plastics production will double until the year 2050 in almost all of the segments wherein plastics are used. You can see them on the bottom: packaging, transportation, building, construction, and so on. In line with this, as the middle diagram shows, plastics waste generation will increase. This especially for the sector of plastics packaging, less for the more durable applications like building and construction and transportation, where on the other hand, you can see on the right diagram, the plastics in use will increase. Well, why is that the case? Of course, plastics are a nice material. They protect persons, food, and goods. They are lightweight, they can be molded easily and at really low temperatures in comparison to alternative materials like metals or ceramics. Plastics are cheap, they are durable, and in use they save energy, resources, and greenhouse gas emissions. But the dark side of plastics, they do account already for 4.5% of global greenhouse gas emissions. To put that, or to compare that, this is twice the emissions of Germany and the Netherlands together. Plastics production leads to fossil resources depletion. And both of these effects, greenhouse gas emissions and crude oil depletion, will increase, or the share of plastics industry will increase in the next decades upon defossilization of the energy sector. And we have a visible problem with plastics, that is plastics litter in the environment. And at this point, I would also like to stress that we should not always look to Southeast Asia or other developing countries. No, that's a photograph taken at a railway station here in the Ruhr area. And we can see a lot of the rubbish that's lying there is made of plastics. And we estimate that the degradation of this plastic litter can take hundreds of years. And in turn, it can negatively affect the environment, for example, by entanglement of animals, by animals eating plastics, misleading it for food. And additionally, toxic ingredients that are in the plastics can emerge on environmental breakdown. Now, what are the alternatives? Here, one exemplary application where plastics are used in a multitude of ways. We see here thermal insulation, we see windows, we see piping and paints in the building and construction sector. Wouldn't it be just easy to replace them by minerals, metals, wood, or some other materials? Well, principally and technically, yes. But lots of studies have revealed that a general switch to such alternative materials would likely increase environmental problems. And this is especially caused by the higher amount, the higher weight of material needed, the less effective conversion processes, and the higher energies, higher temperatures needed for conversion of metals and ceramics. Well, nevertheless, there are alternatives to plastics, like e.g. mineral wool or natural fiber insulation materials. And to compare them and the environmental effects with plastics, we suggest to compare the materials by harmonized and consensual life cycle assessments. And the results of these assessments, in which partners of both industries, plastics insulation producers, as well as the industry from mineral wool and natural fibers insulation, they should team up together, construct the framework, agree on the parameters, and then work on the results. Especially in transportation, we have the case that plastics use can save dramatic energy and greenhouse gas emissions during the lifetime of the material. For example, in aviation, each kilogram of weight reduction decreases the lifetime emission of airplanes in the range of dozens of tons. That is more than 1,000 times the inherent carbon dioxide backpack that the material carries. On the other hand, transportation, especially road transportation by cars, has a drawback, and that is we have tires from natural and synthetic rubber with high additive content that during the use are dissipated as microplastics, and tire and wear road particles are the most found microplastic in a lot of environmental compartments. We need here innovations and harmonized risk assessment in future. Future. What will the future look like? We don't know, either on Earth or on any other celestial body. But we think that plastics will and should remain an important part of our economy and of our daily lives. And our vision on the future plastics economy will now be shown in the next slides from Jan Harm.
Yeah, thanks, Stefan, for this nice introduction. Well, this time, me without all the Lego bricks, still the same person. So Jan Harm Urbanus from TNO. I'm lead scientist for circular plastics at TNO, and I want you to embark on our vision on future-proof plastics as an important ingredient in the circular economy. So I hope you stay with us. Any vision, our vision or others, for a circular economy should meet three overarching goals. We should achieve climate neutrality, we should achieve zero pollution, and also accomplish technological sovereignty. All very important. And climate neutrality is much more than just eliminating litter or leakages, landfilling, and incineration. It's also about a systemic change on how we look at the design, the use, the production, and also the recycling of plastics. If you look at zero pollution, this is a daunting objective for plastics. We talk about particulate matter, as Stefan just addressed. We also look at microplastics and leakage of chemicals. And these are known factors, I think by you all, but also very difficult to eradicate so far. So we see that biodegradability and also the use of safe chemicals is paramount in a circular economy. The third goal, accomplishing sovereignty, I think it has gained momentum during the COVID-19 crisis. By using fossil feedstocks, we have become very dependent on other regions outside of the EU. So by using waste as a feedstock rather than fossil naphtha, we have a crucial ingredient in becoming less dependent. And as such, the circular economy is a cornerstone for this overarching goal. So if we look at future-proof plastics, they need to contribute to these overarching goals. But how does it look like? What are the ingredients? What are constituents of a circular economy? It is not a silver bullet. There's not one solution. It's not one-dimensional. Several approaches are required simultaneously. And over the years, maybe even decades, several publications have attempted to describe what is a circular economy. Think of the ladder of Lansing or the waste hierarchy or the R strategies. And in all of these, the sum of approaches is actually what represents a circular economy. So we believe that all of these strategies can best be summarized as depicted here in this scheme at the right. So we talk about narrowing the loop, slowing the loop, and closing the loop. We think these are already familiar, but we think that it's very important to also reach climate neutrality by adding a new one, which we call operating the loop. So let's take a closer look at those four loops. So narrowing the loop comprises of the R strategies refuse, rethink, and reduce. Essentially, it's about trying to use less material within a circular economy. Operating the loop has three different O strategies. So it's about the use of renewable energy, the use of renewable feedstock, and also try to minimize the waste. Well, if we look at the use of renewable energy, this addresses the scope 1 emissions. So as such, it's very important to achieve climate neutrality. If we look at material losses, we look at losses that are caused during transportation, during recycling, and during production. And these lead to micro and nanoplastics with so far unknown environmental and also health effects. So minimizing those losses impacts the second overarching goal of zero pollution, but it also leads to improved competitiveness of the sector as a whole. And finally, the third O strategy, the use of renewable feedstocks like biomass and also CO2 to replenish, let's say, that what has been lost, is needed for climate neutrality. But it also helps to achieve the third overarching goal, which is accomplishing sovereignty. So if we then look at slowing the loop, this is basically looking at all those R strategies in the middle, where we try to keep all the products that we make as long in use as possible in different means. And this is essential, but also important to have a deeper knowledge of how consumers use products. And we also need appropriate designs that can lead to the further and longer use of these products. Finally, if we look at closing the loop, these comprise our strategies where we try to preserve the materials or the constituents of products after the use phase, preferably with a high quality. Well, if we look at recycling, this comes in many ways. Next to mechanical recycling, we also have physical recycling or dissolution, and we have chemical recycling. If we look at the latter, there we see that we have depolymerization strategies, where we go back to the monomer, or we have so-called feedstock recycling strategies, where we produce a gas or a liquid, which is then being used again as input for conventional chemical value chains. Going back to our previous scheme, we can conclude that so far most of the developments have been focused on closing the loop. Technologies have been developed and are being scaled up at the moment. Legal frameworks are being set in place. And that's very important, but it's still far from enough. If we look at the statistics on EU level, we see that only 30% of the plastics are being recycled. So that's why we think that it's very important that also the other strategies, like narrowing the loop, operating the loop, and slowing the loop, are needed for a full circular economy. Our vision is that we strongly advocate for a shift in focus towards narrowing the loop. Well, to sum it up, before we go to the next speaker, our vision is represented in this scheme. In the middle, we have produce and use. Here we have the industry and the consumers that produce and use the products. And by applying narrowing the loop strategies, in dark blue, coming from the top going to this middle box, we have strategies that, as I said earlier, reduce the amount of plastics that are being used in society. And then if we top that off with operating the loop strategies, this material comes from renewable materials, is being produced with renewable energy, and leads to minimal losses. If there are losses, if these are unavoidable, then they must be safe for the environment and for our health. And thirdly, by applying slowing the loop strategies, like reuse and repair, as plotted here, we see that less material needs to be recovered or needs to be recycled. And then in the end, by applying closing the loop strategies, that what still becomes available for recycling is then efficiently used as a feedstock for new products in the next loop. So such a circular economy contributes to the three overarching goals. It can become reality, but we need a couple of things. We need a cultural turn, the development of new business models. We need holistic product designs and also accompanying legislation. But before diving into the next steps, Jürgen will explain our vision on the hierarchy and ranking of the different strategies. Jürgen.
Yes, thank you, Jan Harm. Thank you, Stefan, for paving the way up to here. My name is Jürgen Bertling. I'm Deputy Head of Sustainability and Participation at Fraunhofer-UMSICHT and also Head of Advanced Studies. I will come to the picture later on. Jan Harm already introduced the difference between O and R strategies. O strategies are to be used in parallel and as complete as possible, while R strategies, on the other hand, should follow a hierarchic procedure from the top to the bottom. This is not new and already known as waste hierarchy. It has been invented by Dutch politician Ed Lansing already in 1979. Subsequently, in 2008, it has been used first in the Waste Framework Directive and also later through an amendment in the Packaging and Packaging Waste Directive. But it has never been fully implemented and applied, while the lower levels are addressed by political set targets for landfilling, recovery, and recycling rates. The higher levels, especially refuse or prevention, reuse or repair, have never been fully considered. Furthermore, there is no procedure for producers how to move through the waste hierarchy. And there are no EPR schemes that cover all levels of the hierarchy. On the other hand, the ranking of all these strategies is exactly what is discussed at the United Nations Environmental Program negotiations on a global plastic treaty in Paris these days. One of the most cited slogans is, "We cannot recycle out of the plastic crisis." However, in the past, there have been a rising critics on hierarchy. Typical arguments are that there is no scientific evidence that a higher level leads to better environmental performances, and that higher levels are out of the scope of waste management. As a result, the term improved waste hierarchy came up, which means that the decision for an appropriate level or strategy should be based on life cycle assessments. In principle, the Waste Framework Directive in Article 4, I think it's 2, not 1, allows departing from the hierarchy where this is justified by life cycle thinking on all the overall impacts. But until today, results of LCA are often biased and uncertain. Reasons are lack of data, variations in the methods, and simply in the interpretation of results. Up to now, there is no standard procedure for the comparative assessment of the different hierarchy levels, and also not for the subsequent approval of the most environmentally friendly one. Despite this situation means no procedure for justification, hierarchy is hardly implemented in practice. What are the reasons, the groundings for a hierarchy then? Even if there is no fundamental proof, most experts and lays expect lower environmental impacts at higher level. In scientific literature, there are discussions that applying the full hierarchy, including the highest levels, means refuse, reduce, and rethink, will lead to dematerialization and decoupling economy from environment. What is not discussed, but what we think is a very strong argument, is that higher entry levels into the hierarchy keeps the following levels or strategies as future options. This is why we are convinced that hierarchy should be used as default strategy. This also means the application of any lower level requires a justification. What does this mean in practice? As a first step, we have to ask ourselves if we can refuse the product under consideration. And only when there is a justified no, we should move on to the next step to see if we perhaps can rethink the product and find a different solution, for example, by combining several functions in one product. If this is also not possible, we could move on to a reusable solution and so on. And only when all these solutions are not possible, then we should go on to recycling or even to incineration. But then how can moving forward to the next step be justified? One option is that we know from market surveys that simply no solution on previous levels and the level under consideration exists. Another way is that there are results from LCAs showing that the following level is environmentally favorable. However, these LCAs have to be conducted in a very different way. Most important, they have to be based on methods and parameter sets all parties have agreed upon. I would call it a multi-stakeholder based LCA. The hierarchic approach covering all R strategies should be applied in regulation in EPR schemes, but also to be used in corporate strategies, in product development, and also in the education of designers and engineers. In our white paper, we have outlined the two examples of bottled water and mulching films to show how the different R strategies will lead to completely different solutions. For bottled water, it could be a single-use plastic bottle, a reusable plastic bottle, or simply a soda streamer, or using a hiking bottle containing water without gas. These differences, on the other hand, will lead to shifts in our future plastic life cycle, business models, and value change. The future regime will depend on the range we are willing to implement the circular economy. When we move from linear to circular only, we will perhaps see a small decrease in resource demand and a small reduction in plastic losses, which means mainly landfilling and incineration. However, increasing internal material flows could demand for additional process energy. If we change the paradigm to circular and hierarchic, and especially address the medium levels like reuse and repair, we will additionally see a shift in the internal flows, which we expect that it will need less energy and would cause less environmental impacts. But we believe that only when we make it circular, hierarchic, and restrained, or sufficient would be another term, means we are also addressing the levels of refuse, resync, and reduce, only then we will see a significant decrease in resource demand and losses and a significant reduction of environmental impact. The question is open: which business models could emerge from this radical shift to refuse and reduce material consumption? With this idea, I will conclude and hand over to Esther, who will now talk about the change processes and the actions we believe are most urgent. Esther.
Thank you very much, Jürgen. For those who joined later, the participants, my name is Esther van der Beuker, Principal Consultant Circular Plastics at TNO, and my part of the presentation is about the transition to circular plastics. And the transition to circular plastics, that is a cross-sectoral change. And for this one, we have to, that science, industry, politics, and citizens are working together. And this structural change can be described by the X-curve that you can see on the screen. So going from the upper left to the right down, you see the breakdown of this system. And going from the left under to the upper right, you see the emerging of the new system. And what we see is that the current linear system is already destabilizing, and that is because of the climate change and because of the plastic littering. And also the new technologies are coming up, so that are new recycling technologies, that are bio-based polymers, but at the same time, the old system should be destabilized or should be broken down. And in the old system, we have some plugins. For instance, the incineration with the energy recovery, on which quite a lot of houses in the Netherlands are dependent on the heat provision. And this old system has to be destabilized. And that can be done, for instance, by a ban on the incineration of plastics that are recyclable, on which now is talked in the Netherlands about this ban. And also in the EU, they are talking now about a target amount of recycled material in new products. But the transition to circular plastics is still uncertain if that goes in a smooth way. And therefore, we need some changes at several levels. And we need changes, the drastic changes at legislation and policy. And that is on to narrow the loop, operating the loop, slowing and closing the loop. So for narrowing the loop, we should make the ban on incineration is a good one to increase our recycling targets. And also the target amount of recycled content in new products. So that is on short-term effects. But for this long-term effects, we should also focus on the production of new plastics, that they are only plastics produced that are recyclable. And also the higher R strategies should be more promoted, like reuse and free refuse. And then secondly, we should also internalize the external cost and the environmental cost, because nowadays the plastics are much too cheap. The plastics, because those environmental costs are not included. And the WNF, they already calculated that the price of plastics is 5 to 10 times higher when you include those external and the environmental impact. And then you should know that the plastic littering and the microplastics are even not included yet in the LCA models. So we need to improve our LCA models as well for that one. And then on the second level, the circular chain collaboration. So what you see is that chemical companies at the beginning of the chain, they have to work together with companies further on in the chain, for instance, with the sorters. And there are a lot more sorters than the large chemical companies. But they have to work together to close the cycle. And what we will see is that there will new players coming up in this field. And also what is important for those industry is that they follow the extended waste hierarchy, which is presented by the previous speakers. And especially when you are looking then at refuse and reduce, we need new business models for that one, because that are completely other business models than that we had in the past. And another important fact is that we have to manage the competition and interdependencies, because when we have at the end plastic waste, we would like to be recycled in a correct way, and actually in the most environmentally friendly way. So that means complementary recycling technologies like mechanical recycling and chemical recycling. And then going to the third level, that is design and development. So what we need is to redesign the polymers, the plastics and the products, so that they are recyclable, but also we have to look at the feedstock, as Jan Harm already told us. So polymers should be made from bio-based materials or from recycled materials or from CO2 feeds as feedstock. And that means that we have much more oxygen-rich polymers, which we have to make sure that they meet the specifications of the applications. And furthermore, we have also to make them that they are suitable for the total, for their useful lifetime, including the several reuse times that they are used. And then finally, we have to develop new recycling technologies, not only focusing on quantity, but also on quality. So both quantity and quality. And then finally, the fourth level is the information and education, which is utmost important that all stakeholders are informed and educated to stimulate also the willingness to change. And the stakeholders, you can think about buyers, investors, product designers, citizens, etc. And what is important is that there is also a clear message is given, so that we all know what is the good way to use it in a sustainable and circular way. And that needs actions from the stakeholders. Here there are some stakeholders presented. So the consumers, they have to ask for the sustainable circular alternatives. The industry and the companies, well, they have to follow the hierarchy. So narrowing the loop and working on operating the loop, slowing and closing the loop. The government and authorities, they have a powerful instrument for the legislation and driving the circular transition to circular plastics. And also they can give stimulating measures to accelerate this transition. And furthermore, the NGOs, the schools and the research institutes, companies, governments, they have all should all take action to really educate and inform all the stakeholders in a proper way and giving a clear message. And therefore, there is also a role for TNO and Fraunhofer as independent research institutes. We can give a fact-based story and and give there the information what is needed to make decisions, and also to make legislation and regulation by the European Commission, so that we get the right legislation into place. And also, because we are independent, we are a good player to connect all the stakeholders. And furthermore, TNO and Fraunhofer, we are also investing in technology, and then especially this technology to fill in the gaps to come to circular plastics. So what we do as TNO and Fraunhofer, we would like to set up also a European platform on circular plastics. And our goal is to connect the companies along the circular pathways and develop new cross-company business models, and to search for suitable solutions for the substitution of critical substances of plastics and for the avoidance of, for instance, microplastics or PFAS from the plastic applications. And currently we are working on a Horizon Europe proposal, and that is about bio-based polymers. And when you know that the current set of polymers, that is an investigation of 70 years of research and scaling up, but we have to do it much faster to reach our 2050 goals. So we would like to use polymer informatics to create the right polymers, and so that we can scale them up quite quickly, and that they meet the specifications of the applications. And we are still looking for industry partners. So if you are interested, please contact us. So coming to the end of this presentation, I would like to thank you for your attention. You can continue asking your questions in the chat, and I saw already quite a lot of questions passing by, so thank you for that. And I would like to give the floor back to Manfred so he can ask us the questions.
Yeah, perfect. So a very nice overview, and we have already seen that. Yeah, we have got a wide range of things to discuss, because on the one hand side, we always see there are technical solutions, there are technical aspects, and they are perfectly for TNO and for Fraunhofer, because we are on the material side, we are on the technical side, we are on the assessment side, so we are very familiar with these things. On the other hand side, we have got the society, and the society is a very big topic, because question is always, do we buy 5 t-shirts for 10 euro, or do we buy 1 t-shirt for 50 euro? And the other question is, when we do it in Europe, this change of behavior, what is with the rest of the world? Because you have seen the exponentially growing capacities going inside the polymers, because other regions are going on, and the middle income of these countries is growing, and so the plastic use is growing. So coming back to your questions, you see it is a very wide range. I think I tell these questions to the whole round. You pick up the question where you say I'm very familiar with, and I address perhaps one of you. So there is one question coming. What are the main issues keeping plastic producing companies from implementing existing strategies on a wider scale? Which scientific advances are necessary to overcome these issues? So, come back to the question, what are the main issues keeping plastic producing companies from implementing existing strategies?
I would like to start. I think when we talk about applying different strategies, it's about vertical integration in the companies. And when we move up, let's say, to reuse, it are large investments which have to be done. And this on a field where we're not familiar with, I think this is challenging for most companies.
Yeah, and if I can add on that, just when you look, for instance, at packaging, which is quite a lot used in Europe, 40% of our plastics is used for packaging, then it's completely needs also a new system. If you are going to reuse, you need to collect it. And how are you collect all those different types of packaging? And that also brings up the question, do we need much more standardization? So standardized packaging so that we can collect it easier. And then when you know that there are a lot of products in the supermarkets, you can think of that is quite a drastic change and not an easy one. But when we are going to use less, when we really would like to use less plastics as a society, then these strategies are needed to fill in.
Okay, because we have got several questions left, and I think also one very important topic is the price for virgin material. So we have got very low prices for the virgin material, and yeah, we have got a controversial discussion about this also. So the next question from Jan-Jaap Volmer: will you be able to include the external effects from plastic waste in the environment into the life cycle assessments?
At this moment, we are working on this topic. We developed a new impact category. It's called plastic pollution equivalent. It has a little bit the same architecture like greenhouse gas emissions, but it's all at this moment in the development stage. We have published it already in a paper. When you send me an email later on, I will send you the link to the publication. But I think this is a very important topic because at this point, from a LCA perspective, it makes sense to litter and to release microplastics because then you are not having a problem anymore in the other impact categories. And this cannot be.
Yeah, and maybe.
Yeah, please.
From the Netherlands, also, I think an inspiring example is that we have the Impact Institute that is advocating for calculating the true price for products. And this has been taken up now at shops. And I think this is a nice example of how we could do it technically. And well, we actually need to do it. It's not a question of why we should do it or should we do it, but indeed, it's how we should do it. And we need to, as a community, develop strategies to do it.
But we are far away from a European standard, right?
Yeah, unfortunately, yes.
Yes.
Okay, perfect. So coming to the next question, I don't know if I just tell her Lydia, because the next name is really complicated for me to speak. What specific measures can the Dutch and German governments take to support future-proof plastics?
Well, I can answer a part of this question. In the Netherlands, they are quite a lot working already on reaching our 2030 goals. So there is a national plan, circular economy, and for plastics, and a transition team on plastics. They are working on it, and they are setting now all types of targets, like ban of incineration of the incineration of recyclable plastics, target amounts which are up to 25-30% of recycled content in plastics. And so there are a lot of more measures that are going to be taken to improve the circularity of plastics.
Okay, so coming to the next question from Cornelissen. How does the panel expect the EU Safe and Sustainable by Design framework to impact the design of new materials and circular systems for plastics? Yeah, okay, Esther.
Well, actually, what you need is, of course, that when plastics are designed, that they are recyclable. And actually, I think there is still some way to go forward, because what you would like to have it to have those design rules based on fact-based data, and still we're missing some data. So we do not know everything about how additives behave, how if you have adhesives, what the influence is on the recycling, the printing, and so. So yes, it will improve the recyclability for sure. Is it sufficient to reach the future-proof plastics? I think we need more data and we need more knowledge to come really to the recyclable plastics.
Okay.
I would like to add something. For me, it's not only designing recyclability, it's also designing reusability and even designing refusability, which is, I think, really challenging when you are working in a plastic company, designing something without plastic. But I think this is one of the main challenges for the future. And it is very important that this is introduced in all EPR scheme, in the German Mindeststandard für Beteiligungsentgelte, to dual systems, and so on. But I think this is really a very important topic for the future.
Yeah, and if I may add on that, because I really agree with Jürgen, is that also in the legislation and the regulation, people should be accounted for that. If they do refuse, now actually it is not measured because the material is not recycled. But refuse is even better. And how should you, bring that in the monitoring, and how should you see what the effects are of that one?
And one previous question was what can be done for stimulation. We could talk about CO2 tax, resource tax, and things like that. But when you are already in the refuse range, this will not work anymore. I think we need something like a funding here to develop these new ideas and new business models doing without, to shift something into the virtual space, to replace plastics by convivialism and things like that. But this is really challenging.
Okay, perfect. Because we've got some questions left, let's come back to the questions again. Now it's a question from Jakob. I think it could address Stefan, because it's about biodegradable and bio-based polymers. And I think coming to also some other questions, the word biodegradable and bio-based, I think the questions are related to bio-based polymers, but I read the questions as they were given. So is it A, technically possible to replace current plastic uses by biodegradable plastics? And B, is that commercially possible?
Well, a good question. I think we can apply that for bio-based and or biodegradable materials. Commercially feasibility, of course, depends on the framework. That was what Jürgen already mentioned in his previous statement. If we add something like a fossil material tax or a CO2 tax on materials, then as well recyclates as also bio-based materials will become more attractive. And on the other hand, of course, presently we have biodegradable materials with approximately or bio-based materials with approximately, and biodegradable with approximately 1% at the of all plastics materials. To ramp them up to get competitive with other materials, it needs definitely enough political and financial funding. But in terms of the times that present plastics take to degrade in the environment, I think it is something which has to be taken into account in the next decades. It is not a solution for tomorrow, but it might be a solution that will be necessary in the 2040s.
Okay. So, because we've got some questions left, I think we should move on. And I think it's also a question for Jan Harm. It's coming from Nina. Shouldn't the proposed concepts be applied to all material solutions? Otherwise, will manufacturers just switch to other materials?
I think that's a very short answer. Yes. And I think I also saw a question about what if one sector does use the framework and another sector doesn't? How will you be able to make agreements between how you incorporate this into LCAs? And I think that's a very valid question. So it cannot be done only for plastics. And I think similarly, if we only do this in Europe, it's also not going to work. So we need to do this together and not just by one sector.
Okay. Coming to the next question from Al-Busaidi. To what extent the current industry has the required capabilities to implement the preferred sustainable solutions?
Yeah, I would say that the current industry has them partially, because I believe that if they would have been cost competitive by now, they would have been on the market. So probably a lot of solutions are available within this industry, but not all of them. Look at the startups that are working on innovative biopolymers. For instance, Avantium, I think well known, not even a startup anymore, but a good example of a new polymer on the market. And we need more of that, but that's only on the polymer side. If we reiterate our viewpoints on refuse and those are strategies on narrowing the loop, we have to come up with new business models, new services that are in parallel to the current industry.
And I would like to add on that, what is also quite important is the acceptance of those technologies by the citizens and the consumers. So that is also, it's not only industry, it is a combination of what I already said, a combination of the industry, of politics, making the right legislation and regulations, the citizens for the acceptance, and also we are still not there with all those technologies. So also we need research to be done to get those circular plastics.
Okay, perfect. Now the question is coming to natural competitors inside the industry. So we are sitting also together at Fraunhofer-UMSICHT a lot of times with kept competitors over the last decades. But coming to the question from George, for the construction industries, what would be the motivation of traditional material suppliers to work together with the plastics industry to create a harmonized life cycle assessment framework? These companies are natural competitors of each other.
Well, I'll try. Of course, it's a little bit of a scientific point of view, and of course that marketing and capitalism are something else maybe. Well, but practically, it needs less time to agree upon framework and parameters of a life cycle assessment in advance of that assessment to be carried out than if every industry prepares their own assessments and afterwards they battle each other. It would mean less effort. Of course, it might mean less business afterwards when you look at the results.
Okay.
Perhaps it's up to the users of these different materials to set up this multi-stakeholder approaches for LCAs. Means architects and end users of buildings, perhaps at first public buildings, and then it should work.
Okay, perfect. So coming to a question from an unknown user, but I think a very relevant question. Fast food, fast fashion, convenience, on-the-move consumption, cigarettes, e-cigarettes, and so on. We know the sources of litter, but governments need to change the system without creating unemployment and lower tax revenue, which is very challenging. So who takes this very big question of changing the system without the third? It's economy, ecology, and social aspects. So here's the question about the social side of the changing the whole system. Who wants to answer?
Yeah, I would like to answer, and I think that is a really good question also, because that really makes sense. And what I already said in my presentation is that we should include the environmental costs and the external costs into the price, so that the shadow prices should be part of the price, and that will increase of the prices. And you would like to have an economic system, but there is also labor, and this can mean that the taxes on labor can be lower. So then the material prices are going up. People going to realize that materials, that they have a price, so they are becoming more value, and you less easy get rid of it. And labor taxes become lower. And then you get a new economy, much more focused on the circular economy. And also repair can be competitive compared to each times buying a new product.
Yeah, and it is really a big cultural turn. And I think it has already to start in education in primary schools to teach children that they do not consume things which are not needed, that they really learn to have a sufficient lifestyle and things like that. And at the end, when things are produced which are not needed, then it cannot is not a proper economy. It's about marketing, and perhaps we need also marketing for sufficiency and things like that.
Okay, coming to one last question, because we have just 1 minute left. A question that I'm also asked a lot of times. It's going around the chemical recycling and the role that chemical recycling plays. So I can give a 3 hours lecture about this topic. But now it's for your round. When switching from circular model to circular and hierarchy and restraint model, I can see the demand for chemical recycling decreases. How important is chemical recycling and circular economy of plastics in the current context? A question from Wong. So who will answer?
I'd like to start. I think chemical recycling will play a role in future circular plastic systems, but it will perhaps not play the major role a lot of players expect that it will have. And especially it cannot be the way that chemical recycling is introduced to save the plastics industry. Plastics industry has to move and to vertical integrate to see new business models. That's my opinion.
And I think the use of chemical recycling when needed will be because of the deteriorating quality of plastic materials in the other strategies. So there will, in the end, always be a step needed to get back to the same quality as we now know. And that's where the role for chemical recycling will remain.
One last addition to that, and it would be nice if in future polymer design would already enable easy chemical recycling, especially via depolymerization. Especially the polyolefins are not the best materials. In that case, you get a mixed output from pyrolysis. But if you have polyesters, polyamides, and other polycondensates, you can get back to the molecular building and make virgin material out of those.
Okay, perfect. So let's sum it up, this chemical recycling question. We have to think of, do we really need all these products and to consume the way that we do? Then we need all the R strategies, repair and refurbishment, remanufacturing, new business models. And when it's coming to end of life, and when polymers are used, at first mechanical recycling, and then mechanical recycling, then the chemical recycling, and this in solvolysis, pyrolysis, and gasification. And so we have to think all together and not just one solution for a very complex system, the circular economy. So I think over the next decades, we come together a lot of times. I say thank you for this great afternoon session. And yeah, see you soon. It would be perfect. Bye-bye.
Thank you. Bye-bye.
Thank you. Bye-bye.
Bye.